Hello. Okay, let's see if this works. Hopefully you can hear me. I've got tea. I've also got alcohol in case I need to hit the Balmer Peak. So there's the red wine. I was having a nightmare because I was trying to use this device, which gets very hot actually, which is an Expert Sleeper's ES8 DC coupled USB sound card, basically. So it's 8 outputs, 4 inputs, and it gets me a really nice clean output from my skiff, except it doesn't fit in the skiff. But it was working really well into like Audacity and my PC, basically, to just listen to the output of my module directly. And then for some stupid reason, OBS, the streaming software, just didn't work, just made noise. So instead, I'm going out through a passive, couple of coils thing, because otherwise I have weird USB noise and then into a normal sound card. So it's a bit noisier, but it works. So last minute, sorry. More wine. Okay, I'm assuming that you can hear me. Thank you very much for joining. Audio is live, so I'm just going to go. So last week, 2 weeks ago, we were bringing up this, which I fancifully called Wagyu. This is actually the second in an attempted sort of 5U. This is 1 inch wide, 5U, 5 HP. I always call it 5U. 5 HP wide module, and this one has a codec on it. So this one we went through the design last time, but it has a STM chip, and then it has a little tiny codec, jobby, and then some op amps. But in fact, before this, there was an earlier module, which is called BBO, which is even more minimal. It just has the STM on it, has no codec at all. And I was going to use it to make a byte-beat oscillator, which I have sort of shelved software for. But this just uses the STM's 12-bit DAC, which is pretty gnarly. But that's fine for byte-beat, right? So that doesn't matter. Anyway, I sent one of these, and the ergonomics of this are absolutely horrible. So when I built this, I didn't realize that basically having a jack plugged into one of these renders the knob unusable, which is why for Wagyu I moved all the jacks to the bottom. But the thing that BBO has that Wagyu doesn't have, and maybe the stream after this one will end up doing a hybrid hardware design with better layout, is it has a USB. So that's actually a USB stick, a little green Lego, non-off-brand Lego USB stick. And originally that was for a keyboard to type code into, a little OLED screen, 2 buttons, which are unassigned as yet. And then it has what was meant to be a gate input. I'm going to still use that as a gate input. So basically that's normal to 5 volts, but you can the idea will be that you can plug that into a thing and generate triggers. And stupidly, I actually run that through a pot in analog world before feeding it to the DAC, which means if you turn the gate down with I want it to be a low pass gate. It will be a low pass gate shortly. So basically, depending on what you set this value to, it low pass filters the output. But what I should have done is kept the pot and the jack input on separate pins, because when you turn the gate down to make it nice and filtered, it's now harder to detect the edges because you've just turned them down through a pot, which is just dumb. So so this is sort of a combined trigger gate input and then a level to set the sort of filtering amount. USB stick. This is an encoder, which we're going to maybe use if we get that far to drive the UI. And as I say, the ergonomics are absolutely awful. So we hopefully won't be using it too much. I'm going to use this one as a retrig button, this one as a reverse button. We're going to have what's called pitch and shape in the original thing. I'm just going to do shape it's going to be a granular sampler. So shape is going to set the start offset in the sample. And that's nice for drums, I guess, because you'll be able to chop the beginning off. And then the pitch is going to be either pitch or time stretch, depending on what you set the options to on the encoder. That's the plan. I've written a rough version of all of the bits, but I've never actually stuck them together. And also the version that the bits I wrote didn't actually work. But they didn't work in ways that I do understand. So hopefully we can make some progress today. I don't know, I'll probably ramble on for my own benefit because this motivates me. This is my hobby time, basically. I only do it in dribs and drabs. And streaming it is proving to be an amusing way to kind of force me to do it and go fast. Okay. Yay. Blah blah blah. Are the silver markings on the Wagyu silk screened or hand drawn in silver pen? They are silk screened in the. I guess you mean the title. That's not silver pen. That's actually. I took a photo of it. I did it with a Sharpie. Took a photo of it and then put it onto a KiCad PCB. So the front panel is a PCB. And yeah, you can basically use the solder mask to do silver stuff, which is pretty. I really like this module, but it doesn't have a USB port. So if I was to make the sort of hybrid thing again, I'd either put the OLED screen on this, or I'd stick with the funky. I like the 8x8, but it's harder to read for file names, sample names. Then again, there are plenty of sample players out there that don't have a screen at all. So yeah, this, but then somehow squeeze a USB port on it. Maybe make it a little bit wider, just to stick a USB port down the side. I mean, I could do an SD card, but the vertical SD card mounting things are a pain to find. And also everyone does SD cards. I think it's more funny to do a USB port. So yeah, I'm tempted to kind of do a version of this at some point if this goes well. Anyway, that's just having a wank. Let's talk about software. So let's go to the desktop with both cameras. Hopefully you can still hear me. Yep. So basically, to talk about what we have here, I'm in the middle of a debugging session. So first I'm going to delete everything. BBO, which is the module, has very little to it. Almost none of the pins are used. It's like it was literally like a joke. It was originally a joke tweet module. So I have 4 LEDs, which are the red and green things at the bottom, the 2 dim as well. That didn't work out very well. A UART, which we're going to use for debugging. 2 pins for USB, which is like literally just connect them up to the USB port. The no resistors required. They're in the chip, so you don't even need any passives. Debugging ports, I2C, which does have pull-up resistors on this one, which is driving the screen. Crystal oscillator, and then 6 analog pins. So there are 3 2 pots, which is the last 2. There are 3 CV inputs, including the gate one, and then that only makes 5. Oh, there are 4 jack inputs, and then DAC out 12-bit, and that's it. That's all she wrote. LPZW modules was basically like making it into a sample player, and I've never actually used a USB fat thingy before, but actually, much as I bitch about this thing, all you do is I went to middleware. I said, yes, I want a USB disk. Actually, the first thing you have to do, that was grayed out to begin with. It was frustrating. So top tip, go to USB host, set the class to mass storage class, drive vbus fs. I have no idea what that's for. So I've configured a GPIO up. You have to set it. You can't leave it as undefined or it complains. So I set it to an output, set it to PC4, which is an unused pin. And I don't know what the point of it is. But anyway, it drives vbus fs, which I think basically means when, my suspicion is it's when it's ready to go, when the peripheral's initialized, it outputs 1 on here to basically say now's the time to power the USB port. But I just power the USB port off the power, the end. So filthy animal. So you set this up first, and then you go over to FATFS and you say I want a disk, and then leave everything else as default, and that was it. And hit compile, and that generates basically a call to. I had to dig around in the internet for a while to figure out, because they don't really document anything very clearly. They do document it all, but there's just too much documentation, not too little documentation. So it also generates this call to host process, which basically pumps the state machine. And it also generates a bunch of slightly annoying, how does it do it? It has a USB host folder, and then it generates this file here, and another one here. I forgot, there's just so much. This is all just so much stuff. And in here you can specify logging and stuff, so you can kind of bind different things. Now, I don't use printf, I use my own debug log. So if I was feeling lazy, I would go through and replace this all with debug log rather than printf. But that's just a top tip. I don't actually need to do that today because it works, but you know, that sort of thing. So you basically root around in here, and then basically there's a little state machine that they wrote. They've sort of written a noddy version of it here, USBH user process, which ends up being called in that pump. And one of their samples basically did this, but it turns out that doesn't work if you do that. So don't copy the sample to do that. However, you can mount the drive in here. So I did half of what their sample did. It turns out that this is already being done in main. If I do look for link, oh God knows, somewhere they've they call. So I don't like their generated code very much, but there it is. So they call USB host init, which is generated code, which then calls, oh, I can't remember, MX USB something something. I can't remember. Anyway, I ended up calling mount in when you connect, which I think is what happens when you connect the drive and then to the USB port. And then when you pull the drive out, you get this, which means you do an unmount. So that's basically the only kind of middleware digging. I was like, get that out of the way. I have no tolerance for middleware at all. So that's my limit of middleware. But having done that, so this is the file we're actually going to delete all of that I wrote piece by piece. What should I? Yeah, I'm just going to delete this. Control Shift End delete. And I have done a little bit beforehand. So if we look at our main, a couple of sort of top tips. Just double check in the chat that I'm not talking to silence. What voltage levels have been using for control? I have been using all of the BBO was a little. I got the resistors a little bit off. Wagyu is a bit better. It's kind of ±5, a bit more. I had a bit of margin basically, so it's ±6, I think, with plus or minus resistance tolerances. And then on the DAC output, I meant to be ±6 as well, but I didn't realize that the STM's DAC basically lops off 0.1 of a volt off the top and bottom of its 0 to 3.3 volt range, which ends up being amplified to 0.5 volts off the top and bottom. And I ended up with something like 4.9 to -4.9 to 4.9 output, which is fine for audio, but it's not fine for if you want to use it as a trigger generator or CV generator, which we don't today, so that's fine. But yes, yeah, the Wagyu does look cool. I mean, it's a little bit, the knobs are still a little bit, I don't know if you can see that. Yeah, they're still slightly fiddly. It's not a performance module, let's put it that way. I think I'd probably go to 6 HP just to get that little bit of extra space. And that would probably give me room to put the USB port on the side as well. So, yeah. Okay, so side note about buttons. So basically, I wrote this little wrapper that just reads input pins, boring. But the way I do debouncing, and I've just got into a habit. Some of this stream is just about the habits I've been building up. I don't know if they're good or bad. They're just habits. Basically, every time I go around my UI loop, I shift. It's a shift register. I shift buttons 4 bits to the left, and then I OR in the buttons. In this case, I only have 3 buttons: the encoder button and the 2 clicky buttons. And then basically, if they're down, I set a bit. Yeah. And the nice thing is that basically buttons looks like 0, and then if you read it as hex, the most recent frame is in the bottom. So like if you've got 1 button down, it'll look like that, or 2 or 4. If you've got some combination, you'll have whatever hex combination. 7 will be all 3 buttons down. And then if you release the next one, it scrolls zeros in, right? Which means you have basically the history of the last 8 buttons. So you can detect edges by basically saying buttons and the last 4 frames. And you can say if the last 4 frames of button 1 is 1, that means that we've just pressed it down. There's been 3 frames of silence followed by 1 frame of down. So that's your first down edge. And you can also do it you can detect it's been held for 4 frames, or you could detect that it's just been released, having been down for at least 3 frames, or up to 8, because we've got 30 bits. So it's just a neat little way of expressing multiple buttons, in this case 4 buttons times 8 frames fits in 32 bits, and then you can just do simple hex magic. So yeah, so I'm just scrolling my buttons. I've got an encval which is magically set up by an interrupt. So as I twiddle my encoder, it increases. So I'm just covering the hardware interface here. I've got a DAC callback which we're going to use to pump the audio. At the moment, it's just waggling the lights. I don't know if you can see, but let me just go full screen for a second. Yeah, at the bottom of Wagyu, there's BVO. Sorry, there's a little red and green lights that are alternating, and that's the line of code that I was pointing at. I'll point back at it again. So they're a bit dim because they're surface mount LEDs, and then just bare PCB shining through. It just about works, but it's not as bright as I'd like. Yeah, so that back and forth waggling basically tells me that this DAC callback is getting called, and every 128 frames, I bump a counter, and every 128 I waggle those LEDs. They're bicolor LEDs basically, so they go red, green, red, green. Boring. For ADC, I have a buffer of I think 16. I think ADC samples are set to 16. So basically, I run the ADC at the same sample rate as that happens as the DAC, which is like 32 kilohertz. And then I just sum, in fact, the last 16 odd ADC values just to get rid of a bit of noise. And then I basically set their back to front. The pots are soldered back to front. That doesn't matter. So I basically just set them into a variable called pitch knob raw and shape knob raw. And those are the two that we're going to mostly use today. And of course, I've got the 4 jack inputs as well. But for today, we'll just use the knobs because I can't be bothered to wire in other modules until we're a bit further along in the software. And we scale it into a float and turn it the right way around, and job done. So basically, that means that now we're ready to just basically do like, to do the UI of the sampler. So because I deleted everything. I wrote a little graphics API for myself. It's 128 by 32 OLED screen. This off Amazon for three quid. I can't remember what you passed to OLED flip actually. Oh yeah, it's a stupid API. You have to pass it a buffer, but you have to pass it 1 byte before the buffer because I'm an idiot. Anyway, it doesn't matter. Does that matter? Do you care? Do you care about ITC and whatever? So we've cleared something, and then the only other function I'm going to call, and I'll show you this function because why not? So I've got this silly, you've got clear, you've got put pixel, you've got vertical line, the sort of thing that Adafruit does for their, I've got a proportional font, I've got invert rectangle, and I've got various fonts that I've just basically, that's it. I've got draw string, so not very exciting, let's draw a string. I think I've got format draw string as well. Which is a bit handy. Where's it gone? Graphics. I just closed it like an idiot. F draw string. Yeah, so that's basically printf onto the OLED. So I can do F draw string 00 font. Oh, it's not going to give me font completion. 32 pixel high. So the whole thing. Hello world. Let's do high, and then let's do the current encoder value because why not? Just to get us going, and then OLED flip is declared in OLED flip, and this is basically one of those bring up the same sort of thing I covered on the last thing. I think this is actually from Adafruit, this particular set of things, and then you basically flip and wait, and flip kicks a DMA, and you can see I've been messing around with like non-DMA, and in the end I got DMA working. But we ought to wait before we flip. So let's do that. OLED wait and then OLED flip. So if the previous frame is still, flipping, is that going to compile? Oh my god, it is. Right, let's hit run and see if it works. Get started. Yikes. Okay, so you have to wait for this silly thing, otherwise it gets confused. So when it puts the breakpoint at the beginning of the program, you know you're ready to go. Okay, we're ready to go. Play. And oh look, it says high 0 on the screen. Can you see that? Maybe I can zoom in a bit on my shaky. There you go. And if I twiddle the encoder, hooray! Look at that. It's a encoder. Hot success. And just to reiterate that, like, the reason I do this hobby is because it's actually not very hard, and I'm just sharing with you the joy of making a widget in your hands. It does something and displays screen, makes noises in a moment and displays stuff, and that makes me happy. And you don't have to think very hard. We're not changing the world. One thing that's like philosophically about software is it's all plumbing. Like, what we're going to do today is make a sample player, granular player probably, if I keep going. And it's just plumbing. Like 90% of what we're going to do, I'm afraid, is very unsexy. It's just basically moving bytes around from disk to RAM in just the right way. And you have to sweat the details. Like, plumbing is so unsexy, and my programming job is just plumbing and plumbing and plumbing and plumbing. But and sometimes you look at the plumbing and you go, well, what's special about this? And I think it is just the details of particularly what plumbing you chose. And what if you the metaphor extends all the way to like makers. If you look at Colin Furze, who's literally a plumber, and the stuff he makes on his YouTube channel, they're just standard bits glued together. So I'm not embarrassed about being a plumber by trade. And what we're doing on the stream is basically plumbing. Right. Oh no, you've lost your debit card. I hope you find it. Running debounce logic in the EUI loop. Yeah, well, it's more that I don't see so much as debounce. It is debounce, but it's also whether or not my UI tick has had a chance to see this edge or not. I could run it in a systick, for example, but you run the risk then of your history kind of scrolling off before you've had a chance to react to it. So I tend to basically do the sampling and the scrolling at basically whatever the rate that I'm consuming it is at. So if I'm consuming it at audio rate, then I do this in the audio callback. If I was consuming this at UI rate, then I do it in the UI thing. And if I'm consuming it at both, I probably would end up actually having two separate things of this, because it means that you can guarantee that an edge always looks like one being fed in at the bottom. Whereas if you're doing it on an interrupt, it might have scrolled past a few. So blah, blah, blah. Yeah, you do that in a systic, that way the timing is constant. Yeah, I guess my point is I don't want the timing to be constant in this case. Was 32 kilohertz the max the board can handle? No, not at all. The DAC and ADC on the STM can do like a megahertz, I believe. It can do like 1 million samples a second. I mean, you can't do much else. But yeah, absolutely. But the point is more that I guess you've got to spend some cycles putting something intelligent into your DAC signal, and we're running at 280 megahertz on this chip, I think. So we've got a fair amount of, maybe it's 180 megahertz. So we've got a fair few cycles to go. But yeah, the actual peripheral, the DAC and the ADC can go at megahertz. Okay, great. Let's do some. Actually, I'm going to do. Let's read the USB stick, because that's what we're here for, really, to get some samples. So WAV files. I've basically shoved some WAV files onto my. So a couple of. I'm going to do a little bit of copy pasting and a little bit of coding, basically. Let's go to sampler. Don't really know how this is going to go. So basically, yeah. So there's a disk path which we're using FATFS, which is bundled by it's an open source thing that STM have bundled and made easy with a click to install, basically. And they, rather than having a colon, they have 0 colon, 1 colon, so on. And I flailed around for a bit. So top tip is like, don't try and do stuff until apply state, which is that dumb little ST or the state machine, ticks over into application ready. And then this is also this this thing, which I saw them use in one of their samples. And a lot of the samples are actually sometimes better documentation than the documentation, because they will have documented this function, but they won't have told you anywhere why you'd want to call it. And I still don't fully understand why I'd want to call it. But well, that's what it is. So, all right, let's do some typing. Am I on the right screen? Yes, I'm on the right screen. Right. Okay, so we're in C. Type def struct. Stample. We're going to build a stampler. So basically, WAV files, we're going to basically do a WAV format parser. And basically, there's a thing called a firmware block, which basically is a bunch of 16-bit. We've got sample rate, and we've got bytes per second. And I've written myself copious notes, basically, so that I can remember how to do this. But that's basically we're going to read that straight out of the WAV file. This is the actual file handle that FAT uses, FATFS. And I stumbled on this thing in the FATFS documentation. I don't know whether it helps or not, but basically, this is a cluster map. So basically, when you open the file, you can ask it to build this thing, and you give it a bit of memory. We have to say how big we want it to be. So let's say it's like 32D words. Oh, by the way, this has got a sector in it. So this is 512 bytes plus some basically stuff, overhead pointers and file positions and stuff. And we're going to store where the data in the WAV file begins and where the data ends and how many samples it's got. I might add some more in later, but that'll do as a start. So yeah, the idea is that we're going to basically parse this WAV file. And because the WAV file is just a standard format, I have that like a library routine that I've been carrying around with me for decades that I'm just going to paste because it's too boring. But basically, you give it we're going to go through it to describe it, but this isn't a stream to watch me typing, so I thought I'd just pre-prepare that one. So basically, we're just going to take a sample, we're going to zero it, we're going to open a file. This is the FATFS API. You pass a pointer to the file name, and the flags, which we want to be read-only. I've got into this habit where I kind of like it. I did this at work at first. I think it's stolen from Go, kind of, ish, as a pattern, where basically if I return null, it means it's okay. And if it's not okay, then I return the error message. This is a shorthand way, which means that the caller can basically choose to log that out. So basically, it's my lazy habit of internal code where it's like, oh, if I want to know why it went wrong, I just return a string. It's just kind of neat. So yeah, we open the thing. This is the magic incantation that I just copy pasted off the. I'll show you actually. Will I show you? I will make a browser window. So if you search for like flseek, which is the FATFS seek function, somewhere it says something like fast seek. Yeah, and I was like, oh, that looks good. I want that. And then it turns out that basically what it does is it goes and reads the sectors that relate to where the file is on disk. And if you don't do that, every time you do a read or a seek, it sometimes has to go back to the FAT tables, and it only has a single sector buffer. So basically, it nukes your buffer, and your read time goes to hell while it goes and looks up where the next sector of real data is. But if you have fs use fastseek set to 1, which st does set, and you do this magic incantation, it will pre-populate the clitable with the clumpt that we gave it, and we said how big it was, and we said create the link map, and that basically speeds up reads and seeks, supposedly. So there you go. This is the first time I've ever used FATFS as of today. So, and a couple of days yesterday, a couple of hours yesterday, felt like days. Okay, now the WAV file. So we are going to read a little header, and basically the first byte is wave, which in ASCII is that, and then the next, it's riff, and then wave. No, it's riff, size, wave. I ignore the size, so basically it's like, check them the same. Then we're going to loop through the file reading chunks. And we read an 8-byte chunk, and if we can't read it, we're screwed, so we hit the end of the file or something. And then we figure out where the next chunk is, and the one trick in here is that basically the WAV header 1 is the size, but if it's odd, then you have to do a padding byte. So that tells me where the next chunk is. And then if the first D word is data, then we've hit the data, so we can just record that in our sample, figure out how many samples we have, print it out onto our TTY and leave. If it's FMT space, then we can read the 1, 2, 3, 4, 5, 6. That's interesting. 2, 3, 4, 5, 6. I think I need to pad this somewhat, unless I misread my own notes of the WAV file format. So let me just go and look at my WAV file format. Malarkey? Aha! Yes, the sample rate is a U32, and this is a bytes per second. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's 8. 2, 4, 6, 8. It should be 16 bytes, which it is. Cool. So we read the 16 bytes into the top of our sample, and then we basically go, oh god, it's a 24-bit per sample, 11-channel WAV file, sod off. Otherwise, we just go to the next chunk until we find the data at the end, and we could pull out loops and stuff, but whatever. Right, there you go, WAV files done in a page of code. That is the correct amount of code for loading WAV files. Probably doesn't work, but it's good enough for Australia. Let's have a quick word on the chat. Blah, blah, blah. Yeah, all right. Yeah, the return string trick is basically Go. They actually have a neater thing where they construct an error from a string, but this is C, not even C++, so good enough for Australia. Right, let's actually read this thing off the off L drive. So what we're going to do is we're going to build a table of WAV files. This is my plan. I have a plan. Right, so we're going to have file names, file names. We're going to have up to 64 of them, and I'll let them be 16 characters long. Nah, 32? 32. And how many of them should we have? So basically, global variables for the win. Scan for WAVs. Oh, void. I'm not a good, I always forget to put void. In C, you have to put void. So if we haven't got any USB ready, then sod off. If we've got already got files, sod off. Right, then we basically, this is how you do directory iteration in, FATFS jobby. So you basically open a directory. It's basically the POSIX way of doing it rather than the, what should we do? If res is not equal to there, okay, then sod off. I suppose I could return an error here, couldn't I? Should we do it again? Let's do it again. Why not? If it's not ready or done, in fact, let's just return 0 because we're happy. This one is like can't open. What's disk path? Did I have a disk path? Yeah, I've set it to 0://. So we're opening the root directory basically. Then while the USB is still ready, because it might go, you don't want an infinite loop if they pull the stick out. And you see I'm sort of writing relatively defensively. I don't know if this is normal, but I tend to sort of I try to sort of either handle errors or pass them up immediately. So apparently, depending on your flavor of your month, you can get to the end of the directory that way. So that'll do. That'll read the files. And now, having found the files, let's actually probably actually going to let's close the directory. Done. Lovely. Let's actually iterate the files. So there are also directories, right? Which is no good. I think that's fattrib. If it's a directory, skip it. Then we'll find the extension. This is lazy man's attempt at getting an extension. I just used str, which finds the first occurrence of that string. It's not a WAV file. Never mind. If the file name is bigger than I'm willing to back up, so that's what that. Oh, actually, no, I'm not going to return. I'm just going to whinge about it. Debug log file %s is too long. And then continue. I'm not going to give up. Okay. Let's open it. Now, annoyingly, the file iteration only gives you the file name, it doesn't give you the full path, but the file open, as far as I know, needs a full path. So let's print out always use snprintf, never use sprintf, just saying. So yes, that prints out, we've already checked that it's not too long, and this would actually just safely truncate it for me anyway. So we'll basically print that out, and we'll try and parse it, right? So we just do our parse wav. I don't think I've declared sample yet, but we'll stick it in there, and then I think we're done for now. I just want to know that the WAV file reads basically is a valid WAV file. And then if there was an error, I will whinge about it but not give up. File %s wasn't a valid WAV file because that'll do. Thanks very much. Right, we're done. Hooray! Success. So basically let's copy this into our file name. What do I call it? File names? I think I called it file names. fname. I should have pulled that out really. There you go. So that copies just the bit up to the extension. Do I need to terminate it? I probably do, because string copy doesn't actually terminate. But these are global variables, so they're already null. I don't have to null terminate it. I'm so lazy. I didn't null terminate. Oh, that's too evil. You see, I can get away with it, but where was I? Let's pull it out. If the length is too long, sod off. Oh, what did I just push? I pushed some shortcut. I have no idea what I just pushed. I don't even know how to get rid of this. That? Okay. Fat fingered it. Okay, we've got a length. And we're going to copy the length. And we're also going to, oh God, don't increment that yet. Null terminate. Gross. And then we can numfiles ++. And then because we're a nice person, we will qsort. Can I qsort the file names? How many files do we have? Can you do that? I've never done that. Can you? Let's try it. Just pass strcmp as the. Sod it. Let's say got that many files. Do you know what we should do? If we run out of space, then we're done. Ship it. I'm ready to run some code. Let's do, what do I even call that function? Scan for WAVs. Scan for, I wish it did autocomplete. Scan for WAVs. Right. Let's also declare a sample. Sample. All right, see if it compiles. Stop. Compile. So if this works, we will have, sad times. What's it whinging about? Unknown type name sample. Oh, because I'm not used to C, sorry. So you have to say sample, sample. Come on. Well, what's it saying? Undefined reference to string copy. Stricken copy, because I can't spell. It's real, people. Is it going to work? Well, should we put a breakpoint? I don't quite believe that this is actually going to get this far. Let's put a breakpoint there. Debug. Take your bets. Waiting. Debugger connected. Downloading. Fast chat and say ship it. Okay. Hit play. Ooh, you're gonna have a good time. Why has it not broken? Did I call? Oh, it did. While USB ready. Omg. Do we have putty running? We do. Right, let's just clear away my old. Clear. Reset terminal. Right. So USB is ready. Oh my God, it opened a directory. It read a directory. It's probably dot. Probably, oh, do we have a, oh, we have a WAV. What's the F name? 18474 pitxc4.wav. I think that's a freesound WAV file. Most of the files on here are just from freesound. It's not too long. Should we step into our, let's just live dangerously. Did it parse? Error was null. It parsed. Holy crap. Close the file, add it to the list. Job's a good one. Let's put a breakpoint here. Get rid of this breakpoint here. Motherfucker. Just delete, play. Boom. That looked like it took forever. But, oh, why? Oh, putty's inactive. Well, that was sad. We just didn't get to see any of our little glorious. Oh, putty. Why do you be inactive? Right. Let's. Why is it printing out the encoder value? Did I leave that in here? Oh, yes, I did. Go away. Right. Run. Compile, I mean. That nearly worked. I think that worked. I think that basically got some WAV files. We just failed to capture RTTY to actually see what the hell is going on. Oh, it's a bit slow, isn't it? Download in progress. Verifying. Run. Oh, that was a bit quicker. Got %d files. Enc vals. Why am I not seeing play? Something weird going on with the breakpoints. Just hit play. Thinking. Hey! There you go. Oh, I forgot a /r somewhere. Oh my God. I think I forgot a /r up here in my copy pasted code. Look at that though. Bad bits per sample wasn't a valid WAV file because one channel 44100 doesn't sound too bad, does it? Omnisphere. Lovely. Got 18 files. Well, it got some. I forgot my new lines, but I'm going to call that a success and move on. Have some tea as well and some wine. I'm basically drinking tea and wine alternating. It's quite interesting. Right. So I tried something and it failed because basically the USB FAT is super slow and I haven't quite solved this yet. So this is sort of a problem. But I was going to do a granular sampler and I think I'm going to overhead some whiteboardy time type. Change the speed. OBS. Overhead cam. Okay, zoom back out again somehow. Wait. Move my T. Slide this off without making the magic smoke come out. All right. Wink. So a granular thing is you have your, I always think of samples as tapes because I long to have been alive at that time. And basically you're just going to have a read head or you want more than one grain at once. And basically your read head is going to be reading from the tape and outputting and you're going to have multiple grains at once. And they're basically reading and they're sort of multiplying by an envelope. So typically you'll have like a triangular envelope or a fancy cosine envelope or whatever. And all your grains are basically getting spawned and reading from the tape, which is our WAV file. And I did a test where I basically just tried to seek for each of these grains and read the sector. And I gave each grain a 1 sector buffer, 512 bytes. And I'd only basically fetch another sector when it needed to. But it didn't exploit redundancy when the grains were overlapping and it was too slow and it glitched out. And yeah, it made me sad. So plan B is we're going to have our WAV file And we're going to have a playhead, which is, oh yeah, we also have a sort of master playhead, which is the one that we control with our sort of pitch and rate knob. And it basically, if you're freezing the sound, then it's sat still. And if you're playing forwards, it's moving forwards. And if it's moving backwards, it's moving backwards. And basically, we're going to spawn grains around this playhead as it moves. And if you spawn the grains jittered, you get like a ambient sound. And if you spawn them exactly on the playhead, then it just sounds like a sample player, which is good. You want it to be able to generate to just play poof, drum sound, or you want it to be able to play ambience. And I've written lots of granular players, including dreams, but there's lots of ways of, again, plumbing. There's lots of ways of plumbing this, and the devil's actually in the details. All grain players are basically the same thing, but how you plumb it matters. And we've got a shitty little USB stick and a very slow blocking only FATFS API, so we're kind of constrained. So, and I'm sure you could do better, but as I say, this is a LPCW modules telling me, let's make a sample player, and I'm like, yes, we're going to do it. If I was trying to do very low latency drum player, I would probably, loading from WAV from sort of USB will always take time. So basically what you want to do is you want to preload the first 128 samples or so of your start point. And every time the start point changes or the sample changes, you fetch them. And then you have a very low latency loop that's basically waiting for a trigger. And as soon as the trigger arrives, you kick into action and start playing back that pre-cached impulse, and then basically get the USB to sort of pick up speed and start reading sectors. But we're not doing that today. We're doing granular, but totally doable. So what we're going to do is we're going to put a layer of indirection, because all computer science problems can be solved with another layer of indirection. So we've got our WAV file, which is being read over USB, which is super slow. And we're just going to shove it onto a mini tape, which I'm going to call tape. And it's going to be like 32,000 samples mono, so 64K RAM. And we're going to try and keep it kind of centered around the playhead. So basically, I'm going to have a valid region which starts empty, and we're going to try and keep the valid region around the playhead. So as the playhead moves, we're going to try and grow the valid region to encompass a sort of healthy chunk either side of the playhead. And I think we'll make it so if the playhead's going forward, we'll have more space on that side, and if the playhead's going backwards, we'll have more space on that side. And I think for now as well, I'm only going to read from the file on the sort of same side that the playhead's going. So if it's going to the right, I'm going to just stack on the right. And if it's going to the left, is that going to be good enough? Yeah, that's probably all right. That's the plan. Having planned it, let's do it. Now, there's also off stream, I tried something else that didn't work. Basically, I've tried two things, neither of them worked. So on stream, we're going to attempt to do the thing that does work, which I've not tried yet. So what could go wrong? Carlos Dios, hello, welcome. Yeah, I'm going to ramble on for ages. I'll archive this on YouTube as well. We've just got to the point of being able to read files off we've got the file list off the drive. Now let's actually read a sample and everything. So let's have some state. What state do I want? I think I want a playhead. So I'm actually going to do a fixed point. Let's have tape actually. So a little bit of copy pasta. So I'm going to have a 32K tape. That's in samples. Most things are in samples if I don't specify it. There's my tape. I'm going to have a playhead, which is 16-bit fixed point, so that we can do kind of fractional stuff, which means it probably needs to be 64-bit. Hurrah, slow, but fine. And this is the rate of playback of the playhead, right? So how fast the playhead's moving. And then this is the region of the tape in samples that is valid. And I'm not going to modulo this. I'm just going to let it be a giant number, right? And I'm actually going to write a little accessor, I think. So get playhead, which just knocks off that 16-bit, fixed point. But it also adds, so the shape input, if you remember, was a 0 to 1 knob, basically. So we want to set the start point in the sample according to the shape input. And actually, I think I'll also do a little. What did I do before? Yeah. So basically, let's do a little bit at the top. We're basically going to take the raw values and clean them up a bit. So shape input, for example, I'm going to low pass filter it a bit more, and we're going to clamp it. So we take the shape input and we scale up by 1%, knock off 0.5%. I don't know if that's going to be enough. Basically, the ADC, sorry, doesn't go all the way 0 to 1. So yeah, maybe I'll make it a bit. Maybe I'll do 2%. So that's basically just clean up the ends, and let's do the same for. Actually, you know what? I'm going to put a dead zone in the middle of the pitch input because I want the pitch input to basically be frozen in the middle, backwards to the left. And so if the raw value is to the right, past 12 o'clock, then the new, I guess it's the raw value doubles, but with a little, just a bit too much. Let's do 5%. And then knock off a little bit. And so that gives me a little dead zone, right? So basically, just above 0.5, that will be negative and then get clamped. Otherwise, pitch knob. Oh, it's actually the same, basically. Is it? Yeah, I guess it is. So we'll just, same deal, actually. I could have written that simpler. But twist. No, I can do like plus here. So what I've done now is, if you're at 0.5, I'm going to increase it slightly. I should go back to the overhead. Oh, fucking hell, I already am on the overhead. I did this on the last stream as well. All right, I'll show you the code in a moment that I just talked through. But basically what I was doing was that I've got a knob which is raw value of 0 to 1, but the problem is it's not 0 to 1, it's like 0 point a little bit to 0.99. So we want to kind of scale that out. And I want a detent in the middle. So I want to map 0.01 to be like that. So I want 0.5 on the input, and 0 and 1 to map to 0, 1, and -1. And now I'll show you the code that I wrote that you can see. Lol. I'm clicking an OBS, thinking it'll move the one noob. Right. So this one is the unipolar one that's just a simple scale a bit, boost it by 2%, knock off 1%, and clamp it. This one is basically like the two halves. And the reason I do the two halves separately is mostly so that I can bias it differently and then clamp it into the ranges. And that gives me that kind of seesaw jazz. Which basically then means I can, and then I was going to low pass filter it. So basically I was going to say shape input plus equals new, this is a 3dB, new shape input, pick a number, I don't know, a bit. So that's like a cutoff frequency, and then pitch input, new pitch input minus, I feel like the pitch one be a bit more responsive. Yeah, whatever. That'll do. Then we scan for WAVs. What was I going to do next? I have forgotten. Oh, I was actually going to load the file. Right. So what we're going to do is, if we've actually got some samples, so we've managed to load a sample. And at the end of this, let's load one. So let's do load sample 1 for the sake of argument. Let's have a cur sample and a void. Did I capitalize that? God knows. S. If S is cur sample, sod off. Then we want to basically do a printf jobby, like basically this again. Maybe I should almost the same. This won't have the wav on the end of it. Let's stick a wav on the end. Let's propagate the error. Happy. I think we just return that. Actually, if we didn't have an error, then set the current sample to S. Something like that. Although then it will keep trying to load it. I'm always going to set it. Okay, so we're just going to load. Did I have a cur sample? I did. Load sample 1. Yeah, that'll do. Right, so now we actually have a WAV file loaded. We're going to try and, read some stuff off it. And this is the one where I haven't actually got it right yet. So I need to go a little bit slowly. But the crazy thing is, it's all about going slowly, people. Let's get the playhead. So playhead equals get playhead. If the playhead has fallen outside our valid tape position, right? Tape valid max. Then we've seeked outside of the sort of range. I'm just going to basically invalidate the entire tape. So I'm going to say tape valid min is playhead. Interesting. Samples. I'm going to do this. Let's do this as, I haven't written this before. Let's do this as sector, playhead sector. I'm going to improvise this. 256 sample sectors. And if this playhead sector is outside of the range of the tape, then tape valid max equals the playhead sector times 256. So basically, oh no, nuke the tape, basically. Now our job is to read in whole sectors, and that's what I didn't do on the previous prototype. So basically, I was reading dribs and drabs. And turns out that FATFS has a little one sector buffer, which is happy to basically copy out of bit by bit for you, but not if you are seeking backwards. Then you basically end up in a pathological case where it's kind of seeking around and it's just no good at all. So our job today is, if the playhead is going forwards, then we want to read a sector on the end of the tape, right? And playhead is further ahead than tape valid max minus the tape size. How much tape should we do? The playhead, as soon as the playhead gets further ahead than 3/4. Yeah, so basically we want to say that the right-hand side of the valid tape is 3/4 ahead of the playhead if we're moving forwards. And then if the, that's D playhead, sorry, if the delta playhead, otherwise the playhead's going backwards and the playhead is less than tape valid min plus tape size times 3/4. So basically, if the playhead has to the left of that, we need to read another sector. Yeah, that'll do. So we want to read a whole sector of WAV. Onto our tape. How's it going? This is going to be a long stream, and I forgive you all if you quit, but I'm going to keep going until I have audio. Can you show screen, please? That's a nice Pico PSU. Yeah, it is a nice Pico PSU. Am I making sense, by the way? I don't know if I am making sense. Anyway, read a whole sector of WAV on tape. The annoying thing is the WAV file ain't aligned on sectors, right? which is a bit of a bastard. Maybe I'll just pretend, I'm going to say that the first sample that's valid is basically the data start divided by bytes per sample, bytes per sample, because you can do stereo, which is annoying. But actually, oh, that's annoying. What do I want to do here? Do I want to do sectors that are byte size, or do I want to do sectors that are fixed sample size? I think I want to do fixed sample size of 256 samples. So the first sample is basically, yeah, that's right. Is that right? Yes, data start divided by the bytes per sample. So it's basically pretending that the WAV file starts at sample 0 at the beginning of the file, and there's just garbage up to first sample. Yeah, that makes sense to me, I think. First sample, that. And that means that basically get playhead, I'm going to actually add sample first sample. So basically, the beginning, you want the playhead at the beginning not to be at sample 0, but to be at sample at first sample. We're pretending that the first sample is not the first sample, whatever. And now that means that we can just treat samples as file offsets, which means that 256 samples are aligned with sectors, which is like joy for the USB. So that little ramble was really important for the performance, right? Because we want to read sector-aligned things. But we also want to think in terms of samples. So we've just redefined samples to be offset. I think that made sense. Right, so basically we can just do an f read, sod knows, sample file. I've got my notes. Okay, so I need to read onto the tape, and I need to read at tape valid max samples, ANDed with the tape mask. That'll do. Yeah, that'll do. And then I want to read basically, if it's mono, I can just read directly, which is what I'll do. So 256 times 2. And it tells you how many it's read, but I don't care. uint, I think it uses. That's mono. So if sample.n channels is 1, then we can just read into place, which is glorious. I'm going to have to pull this out and refactor this into a read sector, but I'll do for now. Otherwise, we're going to read into a temporary thing. Now, I need a 1 kilobyte temporary doodad. I'm later on going to need a mix buffer of that many things, which is 128 times 4, 512. Bugger. 256, hang on, 256 samples, 512, 1K. You know what? 128. Yes, I'm going to do this as a temp buffer, 1K. I'm just going to declare it like that. Right, otherwise we read into the temporary buffer. This is stereo bastard. And then we're basically just going to go down, mono squash it. We're going to have a signed destination, which is just this. What did I just push? Fat finger. Right. This is what it's like when I code at work. Poor people who sit near me. Isolation is a good thing. Hope you're all doing well. Right, so we take destination. You can see I have this sort of habit of like whenever I write something twice, I end up pulling it out of variables. Like, because I'm originally an assembly programmer and I just don't trust the compiler to ever, do the right thing. All right, we set our destination up. So now we can just be like star des plus plus equals temp buff. Oh, I wish it was in sodding shorts. Well, const 16 star source. we can make it so via the magic of casts. Love it. Right, temp buff source 0 plus source 1 divided by 2. And then source 2. Right, mono converted. Did I do it right? Who knows? Probably. What bugs have I written, chat? So basically, we've read a whole sector onto our tape, and that means we can basically just tape valid max plus equals 256 samples. Yeah, because it's all done in 256 sample blocks. And then if tape valid max minus tape valid min is bigger than tape size, so if we've overwritten basically the beginning of the tape, then tape valid min equals tape valid valid max minus tape size. I could have done that with a clamp. Well, whatever, max. I could have done. If the length of the tape is too long, yeah, I think that's right. And then we sort of do the same thing for the rewind, but we'll look at that later. Let's have our D playhead be in normal speed. I don't know what that's going to be, 65536, I guess, because it's 16-bit. So we get the playhead, and then we attempt to read. We work out what sector we're on. That's the other thing. I just pretend I'm the computer and I go through my code again, just see whether it makes any sense. If the playhead sector is outside of the sector range, and I've divided down by 256 basically to do rounding shenanigans, makes sense to me. If we're outside of the range of tape, then the tape is fucked. So we reset the tape. And that ensures that the tape is always on a 256 sample boundary, which is good. And then if we're moving forwards and the playhead is too far ahead, or we haven't got enough tape, basically, then we're going to read on the end on the right hand side. If it's mono, we just read it into the right place. Otherwise, that's good. And then this will be like to do read on the tape valid min side a sector. Basically the same code, just to a different location. So I just need to, we're going to end up doing this at the very end, right? So the min is going to get subtracted. And then if the tape's got too long, then the max is the min plus. I might as well just do it. Should we just call that read a sector? Read a sector. Void read a sector void. It won't be void, but it is for now. Where? Let's give it a where. Int where. Where? We forgot to seek in the file. Huh. Okay, we'll do that in a moment. Read a sector at tape valid max, and this one you pre-decrement because you want to suck it backwards and then read forwards. And we actually need to lseek this bad boy. If where is less than 0, let's do some bounds checking. If where is less than 0, or where is greater than sample.num samples plus sample.first sample, sod off basically. Let's compute our dest already. Memset dest 0. Otherwise, flseek into the sample file to where times 2, unless it's stereo, in which case it's where times 4. Oh, is it going to work? God only knows. Yeah, I like it. God, my capitalization's all over the place. Read a sector, read a sector. Right. So we're basically filling up our tape as fast as we can on the main thread, main loop, UI loop, lol. I'm going to change this to be less blocking, actually. I'll be like, if OLED busy, if it's not busy, we'll do some UI. Doink. I know it's not busy. Hooray. So that. So hurrah. Compile. Are you with me? What time is it? Coding takes so long. Bloody hell. I will get to audio, people. You don't have to stay with me, but I'm going to get to audio. I'm going to keep going. It's been one of those all-nighter streams. It's not, but I reckon I've got another hour in me. No, I don't want to proceed with launch. I want to just see all my typos. What's it whinging about? Sod off. It's called file name. Right, this is where I start just swearing as I fix all my typos. File names S. La 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 pars wav. I'm going to put a breakpoint in this bad boy, actually. Come on. What's it whinging about now? Q sort, whatever. Sample has no num samples. Indeed, it doesn't. Num samples. Consts. Did you mean const? Yes, I did. What's it whinging about now? What? Oh, let's just hit compile again, see what it. Tape valid min valid. Thing is, I'm used to autocomplete, so I don't make so many typos. Also, this laptop keyboard, it's not as beautiful as I should plug in my clicky keyboard. Oh, the glory. I'm almost tempted to plug in my brand new clicky keyboard. Tape valid, valid again, valid min. Shall I plug in my clicky keyboard? Will it make my joy complete? I don't know. It's only a meter away. Compiled. I can't resist. I've got to run. Are you enjoying it, stream? Have you all fallen asleep? Is watching me program glorious? Couldn't you squish the stereo in place and then read sectors at twice the rate? If you did it in place, you would be overwriting more of the back end of the tape, right? So we've only got 64K of tape. And if I read 256 stereo samples where I only wanted 256 mono samples, I basically use up 512 samples worth of tape. So I might as well read it into a temporary buffer. I've got to basically read, modify, write that memory anyway. And I might as well not trash 256 samples that I don't have any need to particularly trash. Yes, that is why. Hit play. Oh, it's loading a sample. What in God's name? Step over. Error? Please say no. No error. What does Putty say? Putty says 2 channels, 44.1, 16-bit, couple of million samples. Bargain. Right, let's have a look at our sector rubbish. So we hit play, and we have samples. The playhead's probably near 0, but not. Ooh. Oh, my shape knob's all the way up. Lol. How's me tape looking? So my tape is. Oh, good. Look, we're testing all our code coverage. So our tape valid is going to like 983, 808. 808. It bodes well. Our playhead is a little bit ahead of that. Yes, correct. The playhead's moving forward, and we definitely don't have enough shit on our tape. So we're going to step in. If this is all right, it's just plumbing, right? We're not out of range. It is stereo. We do want to seek to that play. How many samples did it say there was? We're at sample 1 million. Said there were 2 million, so we're okay. So we seek to 4 bytes per sample because it's stereo. We read, let's actually see how many we read, not the code checks. Yeah, I'll take that. Then we squash that shit down and we come out. Whoa. Done, done. That is, as they say, functional. All right, people, we've read from the USB stick. Oh, actually, let's look at tape. Hang on a minute. Oh, I forgot to look at. Oh, let's just look at it. I don't know. Here, play again. Read another one. Yes, read another one. Right. If we look at dest minus. Where's me? What? How do you even use this god awful? Which of these is watch? Expressions. Yes. Add tape. No, let's add dest minus a bunch. Dest looks nullish. Why is dest null? Why is dest null? Where? 0. Dest. Oh no, what? Oh. What? What was tape mask? I am worried. Okay, there's my tape. What? What is where and tape mask? 1024. Well, that's not too bad. So let's have a look in the tape at a little bit before 1024. Like 900. Ooh, nothing there. Nothing there. Nothing there. What the? Set dest. Why is dest? Oh, sod. Missing ampersand. There you go. Noob error. There's probably a warning about that. I think I just trashed my interrupt table. Well done for not crashing, little STM. Meanwhile, back in the chat, do it, new keyboard, address of, Sam Littlewood saw it, Sam Littlewood wins. Okay, I'm getting my keyboard. It's going to click. My USB bus is probably going to explode and run out of energy to power the clickiness. The clicks are electrical. Right. Listen to that. Oof. Oh, but I've got a mouse, and I haven't got enough ports for a mouse. Oh, it's a nightmare. I don't even know what to do. All right. Touchpad and a mechanical keyboard. It's very weird. This might not work. I might have to put the mechanical keyboard. I don't know. I just don't know anymore. Right. That was a aside, wasn't it? I've been going an hour and 20 minutes. I'm going to keep going. Stop. It's a play. I'm going to start again, and we're going to look and see if we've actually got audio. Now, so I'm going really slowly. As in, I check and triple check and do everything 9 times before I run and then after I run, and it still catches mistakes. But it's just, when you don't know the stack very well, I don't know the USB stack very well, I don't know the FAT stack very well, I don't know STM very well, I don't know this IDE very well. Any assumption you make is going to send you into a cloud of, I don't know whether it's the hardware, is it the software, is it my knowledge, is it the algorithm, yada, 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 yada. So I'm just, you speed up slowly as you get more used to these things, but it always pays to just go, it's got so many breakpoints. Okay, here we go. Let's look at dest. Is dest sensible? Glory, tape plus 2048. And if I hit play to here, dest is now tape plus a whole bunch. And over here, tape plus, I think it was bytes, so I think it'll be like, yay, samples, people. Right, let's actually play some stuff. Let's do void sampler audio, and our job is going to take a half, and we're basically going to make a destination of, I think it's called DAC buff 1 because they have 2 channels, plus block samples. So basically I have 2 double buffers, so it's a dest left and a dest right, stereo out. And we are going to do block samples, and we're going to get the playhead because we can get the playhead. And then we're going to play it. So we're just going to do dest L++ equals tape, and with mono, so we'll just do tape, playhead, and tape mask. I mean, bargain, right? And then I'm actually going to do this in, it's gross. Yes, for now I'll do that. Playhead 16 plus equals d playhead. Moves the playhead forward, and this does some unnecessary amount of work. I wouldn't normally call that an inner loop, but I just want audio. That's all I want. Loop over the samples. In a way, this is sort of granular, right? Because we're just going to fill 64 samples, which is what block samples is. Block samples is just 64. From the playhead, from the tape, I should say, and then advance the playhead a little bit, and then done. I mean, basically, we just have to call this from main inside our sampler audio. I've been experimenting with doing this on various things, but I'm going to do it from the interrupt callback. I don't know if you think that's a good idea, Eric, or not, but I'm going to do it. So we're finished with the first half. What does that mean? Half complete callback means that we've finished transmitting the first half, which means we should overwrite the first half. And then this one basically means we've completed the entire shebang. Let's do it first. So we should do the other half, and then we should compile, and then we should hear audio. Maybe it will. I don't know. Run, remove all breakpoints. Remove. Will it work? I have no idea. Aha. Yes, 12 bits versus 16 bits. That's not going to work. Where was I? So we are going to take this, and we are going to shift it right by... I'm going to do a little fun bit of DSP because I chose a change of pace. I'm going to do a soft clipper in floating point because I think in the end I'm going to end up in floating point land. And all I'm going to do is x over the square root of, it's sort of an 8-hand is my favorite one, but this one is quicker. So the idea is that as x goes to infinity, this basically turns into x divided by the square root of x squared, which is just x over x, which is 1. And x is minus infinity, you get minus 1. So this is basically in the overhead with the Sharpie Cluedo. We have just made a sigmoid, like that. Bargain. Right, it's a little soft clipper. So I want to basically read some audio, and I'm going to convert it to floating point now, because I think it's just going to get easier. And then I'm going to soft clip that bad boy, but I'm going to drive it a little bit. So, because I'm evil. And I'm going to shove it out the clacker. So audio. Now I happen to know that my DACs are a little bit offset and they're DC coupled. So, and then take the whole thing down to an int. Right. So we could do some dithering here as well. Could we do some dithering? Anyone want to see dithering? If you set up the DACs correctly, they'll look like 16-bit. Yeah, I wanted to talk about this actually. Yes, I could do right aligned or left aligned. They're not currently. I like them being. Yeah, I need to convert to offset anyway, and I know that, and I also know that my 0 point is at 1844, not 2048. So I wish that ST would do a thing where basically you could do a delta sigma on the least significant bit. So basically, you could feed it 16 bits or more, and configure it in a mode to waggle the LSB of the 12-bit DAC for you using a counter overflow. It's a really cute trick. You basically just take your the bits that you can't do as a real DAC, and you accumulate them into a little counter with an adder on the chip. And then every time that counter overflows, you should have a 1 in your least significant bit, or you should add 1 really to your 12-bit value. And that way they could basically fake a higher resolution for us, if for us audio rate people, right? Because their DAC can do like 1 million samples per second. So they could be waggling that away up at like way above our Nyquist, and then we just low pass filter it in the analog domain. And wouldn't that be nice? Anyway, it doesn't matter because Wagyu has a codec, and this, yeah, it doesn't matter. I'm rambling. Eric, why didn't they do that? Tell me. ST, why didn't you do that? It's just an adder and a bit waggler. Anyway, I have no idea if this is going to work. Did I call it? I did call it. I think it's just going to work. I have no idea. It's a piano sample, I believe. Download in progress. I didn't wait for it to finish. Oh, I see. Now it gets complainy because I didn't. Oh, I have no idea if it's running now. Because they weren't thinking about audio. Yeah, I know they weren't thinking about audio. Bastards. And yes, you can slap a codec on it for not much effort. So, but still, I mean, they could just, the marketing department would love it. They could be like, higher than 12-bit DAC, brackets, sigma delta, it will be great. Now, I've got something happening. Oh, I don't see anything on my, oh, that doesn't look good. I'm seeing some stuff on my, let's unmute. Okay, everyone close your ears, right? This maybe I'll bring it up. Let's focus right. Let's turn it down. This is gonna, what? Doesn't appear to be making any audio. I wonder whether I should do this in 2 parts because I'm starting to get tired. I've got about half as far as I thought I'd get. Oh well, streaming time is slower than real time. Let's see what's happening. So, half buff, we are getting called, which is good. So playhead, does it look like about 1 million? 3 million already. That's why I'm not hearing anything. Let me turn my knobs down, so to speak, on me thingy. Start from the beginning, basically. It didn't look like audio that I was expecting. So where's the deliberate mistake? Playhead. Dest is being increased. DAC buff, half buff. Yeah, looks all right. Oh well. Oh, I'm going to turn my focus right down again because it's potentially a bit loud. Right. Audio programmers learn a reflex of like when you're running audio code for the first time to take your headphones off because it's like you're about to get deafened. Ooh. I might make it be a sine wave in a minute if this doesn't sodding work. Right, my Focusrite thing is showing audio, but OBS isn't, which means that it might be OBS is crapping out. Audacity. Let's see what Audacity says. Strings up here. I don't know whether. No, this thing can't record at the same time as OBS. Oh, good. Hardware issues. What happens if I delete and re-add the Focusrite? Do you think that would work? Does anyone know how to use OBS? Because I can see the. Okay, I'm going to change this to a sine wave. In fact, I've already got it as a sine wave. In fact, all I need to do. Okay, so we're now into streamer noob nightmare. So I've had it outputting a sine wave the entire time because I pre-fill my buffer, as I did on the last stream, with a sine wave. So let's hit run one more time. I've commented out our glorious audio code, and we should just have a sine wave playing, and then I will fiddle with OBS until we can all hear sine wave, because I can't hear sine wave. But I can see a little green light on the. Oh, I clicked it too soon. Like an idiot. Oh God. Right, I can see a green light on my. Right, it's just sodding OBS that's destroyed itself. Right, Focusrite, delete. I am deleting Focusrite. I apologize if you work for Focusrite, you've been deleted. Audio input capture, add existing Focusrite. You, still nothing. Rubbish. Okay, delete Focusrite, add Focusrite. New capture. Audio input capture 2 from Scarlett. Blah blah. Oh, unfreaking believable. It's just not doing anything. Okay, so I think my USB is crapped out. Maybe because I plugged my keyboard in. I bet you it's something dumb like that. Does anyone know new Kickstarter thingy with H7 RAM codec on a stick? The Daisy. Oh yeah, the Daisy thing. Yeah, I saw that. I felt like it's fun, but it's fun for people like us. But then it takes away the fun of making it yourself, which is like half the fun. And then software-wise, it wasn't very interesting. So I felt like Daisy solved the problem that I didn't need solving for me, really. I don't know. I don't know. It's a nice dev tool for trying stuff out. It will be interesting to see how good the DSP library is. Yeah, what Eric said. That's a nice way of saying it. It did. Another way of saying what I'm saying is like, who is it for? I guess it is for people. I mean, Eric, in fact, made the dev board that I believe was used by Tom Erb to make the Erb verb. So that has done a great thing for the world, and dev boards are a great thing. So there is an audience of people who don't want to have to fiddle about with the low-level stuff, the hardware. But at some point, you're going to want to make your own module or make your own thing and have to make your own chip, and that's really fun. So I wonder. Right, anyway, people, do you know how I can make OBS work? If I quit OBS, right, and restart it, which is my normal way of doing it, is it going to break the YouTube stream? I don't know. Like, how do you make OBS not be shit and sort of redo? basically I know that my Focusrite is recording audio, but we can't hear it because of OBS. I'm going to wait. There's a long latency, so I'm going to wait for the stream to catch up. Drink some tea. Yeah, I think everyone's gone to bed. All right. I'm going to try. I'm going to try Googling it on stream. Can I reboot OBS mid YouTube stream? Can I reboot OBS mid YouTube stream without fucking the mission? I can. Ray Bowling says yes to something. I'm going to take it that he's saying yes to my question. And I'm going to just restart OBS. If this craps out, I apologize. OBS, where are you, OBS? Die. Stupid program. Hello? Can you hear a sine wave? Hooray! You can hear a beep. Right. Is it a reasonable balance? I will, because I can't actually monitor my own voice. I can only hear the beep. Okay. Let's hit play and see whether or not. Oh, let's call her. All right. So it turns out I just needed to unplug and replug my sound Focusrite adapter and reboot OBS twice because computers. So that was a complete waste of 10 minutes. Loading, thinking, running. Oh, did I just do it too quick again? Audio. It's kind of cool. Let's turn that down for a second. So let's look at the valid tape min max malarkey. So playhead is around 1 million. And the tape min 982 and max is, oh, that's suspicious. Tape valid min is 982 and 982. Whereas playhead, do you know what's happening? The playhead is getting ahead, so to speak, and it's resetting all the time. So if I get rid of this for now and just let it grow from nothing and try again. And to be able to play. We might need to hit to go to release build as well, because debug build is gloriously slow. I basically was expecting to see the tape being significantly larger than the currently active sample, basically. That's really interesting. So if we look at the playhead max, tape valid max has only got to 100K, where the playhead itself has got to like way through. So basically the playhead is going far too slowly. Let us not bother with the OLED display. Let us also try a release build. So basically what we're hearing there is the playhead looping over our 1 second or so buffer, 32,000 buffer, and then the reading process just not keeping up at all. So the USB is just, ridiculously far behind. I wonder if it's accidentally scanning for WAVs every time, or something dumb like that. Why it's so slow on the reading side. We'll find out in a moment. Do I know if the USB MSC class and FATFS is fast enough to keep up? No, I do not. And discovering such things ahead of time would be sensible. I do know, however, in my experiments that I was able to make a simple WAV player work. That was one of the elements that I got working pre-stream. But I haven't tried it with this configuration of the main thread doing reading and the audio thread doing copying to the audio buffer. What I did off stream for the simple WAV thing was basically just the main loop, basically spin, waiting for the interrupts to happen to kind of toggle the DAC output buffers. So everything was just blocking, and it was able to play WAVs fine. We're still playing a debug build, which is super annoying. So quirk of STM32, if anyone's watching, even if you select release there, it can still do debug here because God hates you. So the way I know is because it showed me source code, which is helpful. If you're in a release build, it doesn't show you source code. So in about 5 seconds, when it's downloaded it, it will show me precisely no removal breakpoints because they're pointless anyway. See what it sounds like in the now that's annoying. That's OBS again. Yeah, OBS has just dropped my audio again. Bastard. Oh, I'm gonna try that unplug and plug thing I did. I think the gods are telling me that I need to end the stream fairly soon because mother sodding OBS is causing us problems. That's not the point of the stream at all. I will run it again. Basically, I can see the LEDs, the VU meter LEDs flickering. So our shit is working. Oh, I had a click. Sounds like it's occasionally not quite keeping up. So in release build, it's doing better. Still glitching a little bit. It's interesting. I'm surprised. I'll probably have to futz around, try different sector sizes and stuff. Let's try, just to wrap up, if I advance the playhead more slowly, I mean, we have horrible grains here, 64 sample grains. They're not really grains yet. They just read from the current playhead at the end. But if I just set D playhead to be less, like a third speed, let's just, actually, do you know what we should do? We should actually attach it to a knob. That's what we should do. Where was I updating that? Let's move these to be in the audio. So let's do update knobs void, and then we'll do the update knobs there, and then we'll do the D playhead times the pitch knob, which is called pitch input. And I've actually got that turned all the way down at the moment, which means it's backwards, which is not what I want. So I shall turn it all the way up, which is what we were listening to before. Update knobs to D playhead is blah. I wonder what I will do about this if you want more sample. More sample. Oh, listen to that noise. Whoa. Doesn't do that with the ES8. I don't know what that noise is. Gross. It only happens as well when I've got the Nucleo programmer plugged in. So something in my USB ground loop. Don't know. Don't particularly care. And look, yeah, like it just changed, right? The noise just changed as I. Oh, stupid machine, right? Play. Oh, that's a bit loud. But now I can turn the pitch knob. Why is that going lower in pitch as well? That I wouldn't expect, because we are, I guess that's because the grain size is so small, 64 samples, that you're actually hearing the spectrum smeared by the chopping size. It's kind of cool. It's not actually. Anyway, there you go. I think that's good enough for a first stream, actually. I wanted to do a lot more. I had a nicer granular stuff, but OBS has got in our way, and my tiredness has got in the way, and FatFS's slowness has slightly got in our way, which is something the rest I have solutions for, which is just type faster and be more awake. But yeah, FatFS being not quite keeping up surprises me. I wonder how ST have implemented the USB in the background, because I assume that basically it's a DMA. It just sits there spinning. But I'm surprised at how slow it is. Perhaps reader sector shouldn't do a seek if it doesn't need to. Where is going to be going up by 256, so that, yeah, shouldn't need to do a seek. But as in, it shouldn't cost anything to do the seek because it's a no-op. Well, I guess I could always mandate mono samples in the worst case, but I mean, that's kind of shitty. and that may have to be what it is. And then we don't have to do the downsample. Yeah, I think that's cool. Do you have an envelope on the grains? Was it just a rectangular window? Yeah, no. So this is like, this wasn't the granular I was intending to do. I was intending to do a proper. I do have a much nicer granular thing. Well, it's really easy to write. You just write a window. But I've run out of energy on the stream, and all I'm doing there is we've got our main thread, which is filling up the tape. And then we've got our 64 sample, mix some really good quality granular audio, please. And all that does is reads 64 samples off the tape. Oh, you know what? I know why it's pitch shifting, because, I see. What's cool is what we should do here. Okay, I can't. Yeah, such an idiot. Right. I should do playhead plus plus here so that we're not pitching it. But then we add this times block samples here. And then we're good to go. Oh, I'm such an idiot. Right. See, that's why I'm tired. But yes, no, I'm not doing anything. I'm not even attempting to do anything nice. But it'd be trivial, right? Like, so originally I was like, oh, I'm going to do a DSP stream. The DSP on this audio on this stream is this block of 5 lines. So it's taken me two hours to get to 5 lines of DSP. So my prophetic everything is plumbing turns out to be true. But we've done really good plumbing. We've got like a lovely 64K circular buffer of tape. We're reading from it on another thread. We're populating from the USB stick. Rah rah rah. And then this is just copying 64 samples off. But I was actually effectively point sampling, which is why it sounded horrendous. By incrementing playhead by 1, I'm now going to always preserve the pitch. But then at the end of the block, I'm only going to advance the playhead by the amount asked to. So now we'll actually get a proper pitch shift. Sorry, time stretch type effect. And the other knob is actually going to be seek. So you'll actually be able to seek around as well, which is hilarious. But I will hit play first instead of rambling. Play. Oh, I pushed it too soon. I don't know what that means. Will it play? Maybe. That's kind of cool. Yeah. I mean, obviously, if you have decent grains, then it would be better. Stop. Yeah. On that gloriously good sounding end point, I'm going to wrap it up because I think it's midnight. 64 samples is too small. Yeah, I mean, yeah, exactly. The DSP on this is like horrendous. I wonder why deep. I'm so tempted to see. This is a problem. I can't stop myself. I wonder why deep playhead was so. Oh, I'm an idiot. Fucking hell. I'm tired. That line needs to be there. This needs to be release build. Let's have one last stab, guys. Because otherwise I'll just kick myself. Did everyone spot the mistake? Is it instructive to tell you the mistake? Basically, I was recomputing playhead every time through the loop, so incrementing it is pointless. So I pulled it out the loop, and now I'm actually going to manage to write a 64 sample copy. Like, can you believe it's? No, I shouldn't be allowed to program this late at night. Right, 3, 2, 1. I'm going to wait this time. Turn it up. Yay! There we go. And if I turn this down, it still sounds kind of pitchy, doesn't it? Yeah, that's cool. Anyway, for grains you want, for ambienty stuff like this, you want 1,000 to 4,000 sample grains, and you want lots of them overlapping, which is what I have in a paste buffer off to the side. But we didn't get that far. I need to fiddle around more, I think, with FATFS first to make that really robust to the simple case. A little perplexed as to why it can't even manage, one stereo sample off USB. And then I will do another stream one day, or maybe I'll just write the code and stick it on GitHub of something nicer sounding and stick just a demo video up. I don't know. Depends on whether you want more of this or not. I hope you enjoyed this. I hope it helped see that the plumbing, at least for USB sample player, is relatively simple. And that once it gets to midnight, I shouldn't be allowed to write DSP code. Otherwise, I've obviously turned into a pumpkin. And yes, thank you for tuning in. And maybe there'll be a part 4. I'm not sure. I don't know. Feels like maybe not. I can't tell. Lots of love.